Without further delay, I will launch us into this panel discussion. So thank you to both the panelists and for the attendees for joining us for the LEAP Wallerstein panel series on AI and extreme weather preparedness. Our session today is on the use of data and AI for decision making, decision support, and policy. So my name is Geneva List. I am a researcher at the Columbia University Climate School, and I'm jointly affiliated with LEAP, Learning the Earth through Applied Physics, or AI and Physics, and the National Center for Disaster Preparedness. This is the third session of our panel series, and it aims to provide a platform for interdisciplinary dialogue, as well as knowledge exchange between academia and the broader climate resilience and disaster community, particularly on artificial intelligence and machine learning applications that can really help us to enable extreme weather preparedness. Today, I'm particularly excited to bring together a panel of truly interdisciplinary experts to discuss how we can get from data to action and the role that AI can play in helping us get there. So to begin, I will introduce our three panelists. I'll start with Dr. Miguel Angel Fernandez Torres. He is an assistant professor at the Signal Theory and Communications Department of the Universidad Carlos III de Madrid, Spain. Previously, he was a postdoctoral researcher at the Image and Signal Processing Group at the Universidad de Valencia, Spain, where he took part in several projects focused on machine learning for modeling and understanding extreme weather and climate events. And he currently co-leads the Working Group on Data at the Global Initiative on Resilience to Natural Hazards through Artificial Intelligence Solutions at the International Telecommunication Union of the United Nations. His research involves explainable deep generative models and machine attention mechanisms for anomaly and extreme event detection. He holds master's and doctoral degrees in multimedia and communications from the Universidad Carlos III de Madrid, Spain. Thank you for being here, Miguel Angel.
Thank you for the invitation.
You're welcome. Our next panelist is Dr. Akeisha Glenn. She is a civil engineer who helps cities develop strategies to mitigate the impacts of climate changes. Dr. Glenn specializes in quantifying regional climate risks centered on hazards such as flooding, extreme heat, and large-scale changes such as warming sea surface temperatures. In her current role as a senior planner for the New York City Metropolitan Transportation Authority, the MTA, on their climate resilience planning team, she works on assessing and identifying climate hazards and the risks they pose for MTA's infrastructure to help develop mitigation strategies for capital projects. And before joining the MTA, she worked on climate change analyses of the Caribbean, New York City, and the US Northeast region in collaboration with NASA, NOAA, and the City College of New York. So thank you so much, Akeisha. And good morning. And we also have Dr. Terry Adams Fuller. Dr. Terry Adams Fuller is a professor in the Department of Sociology and Criminology at Howard University. She serves as the Deputy Director of the NOAA Cooperative Science Center in Atmospheric Sciences and Meteorology at Howard University, and the Director of the Howard University Initiative on Public Opinion. Dr. Adams' specific research interests include emergency management, behavioral responses to severe weather and climate, as well as the impact of trauma and disasters on individuals and organizations. Her work centers on individuals and organizations' decision-making process in the face of crisis events. She holds master's and doctoral degrees in sociology from Howard with an undergraduate in government and politics. So thank you all so much for being here.
Thank you.
Excellent. So to launch into discussions today, we'll start with hearing from each of our three panelists and an introduction of their work and their research as it relates to disaster preparedness and climate resilience. And in particular, I'd love if you can touch on the types of data that you use and work with in your research or in your operational planning and decision making, and whether or how you are integrating or planning to integrate artificial intelligence or machine learning models into your work and research. We'll start with Dr. Miguel Angel Fernandez Torres. I will share my screen for for some background slides, and then we will jump to Akisha and then followed by Terry. Right. I trust folks are able to see my screen.
Yes, I
Brilliant.
think so.
All right, Miguel Angel, please take it away.
Thank you so much, Geneva, for the introduction and also for welcoming us to participate in this panel. I think it's very important to share our thoughts. This is a brief summary of the research we have been conducting, although I currently am assistant professor at Universidad Carlos III de Madrid, the Department of Signal Theory and Communications. During the last 4 years, my background is on computer vision, but during the last 4 years, I have been doing a postdoctoral stage at Universitat de Valencia, the Image and Signal Processing Group. And there I started applying computer vision, machine learning, deep learning to extreme event modeling and understanding. We have been participating in several projects. We have had the opportunity. We have been particularly focused on droughts and heat waves. And we have been using deep learning in order to try to detect and to forecast these streams and also to understand a little bit better these streams, because in the end, the definition of these streams is quite diverse. We have multiple perspectives in order to understand a drought from the agricultural perspective, from the socioeconomic perspective. So we have tried to take into account methodologies in order to do this. Here, I summarize two of the works. We have been working with the ERA5 reanalysis data, climate variables such as soil moisture, temperature to meters, features regarding vegetation health, such as PAPAR index or leaf area index. Together, combining all these variables with deep learning architectures, modeling spatiotemporal dependencies, temporal dependencies, also sometimes with drought indicators in order to take into account domain knowledge, we have been able to design systems to detect droughts. We have been conducting experiments in Europe, but these are still generic systems. These two ones I have here are supervised. They have been led by two of my PhD students, Monche and Jordi. And we have been able to improve a little bit to discover better how droughts are working, in this case, in the European region. We are also interested in explainable AI in geoscience, and we have been doing an effort in order to understand better, in order to see the techniques, the strategies we have for explainable AI, in order to better understand the models we are using for drought detection. If we go to the next slide, because this effort on explainable AI, it's part of the story or the reason I had the opportunity of participating in the global initiative. If we go here, and I want also to take the opportunity to give thanks to Monique Kuglish, who is leading the global initiative on resilience to natural hazards through AI solutions. There I have the opportunity of co-leading together with Arif, also Handra coordinating the working group on data. We have multiple groups, and our objective is to try to standardize the techniques, artificial intelligence, or from multiple perspectives, from the data perspective, from the modeling perspective, from the climate perspective, to try to propose best practices, to try to review use cases together with a group of experts worldwide. I think it's a very nice group. I wanted also very briefly to take the opportunity to introduce that we are having the second meeting of the Global Initiative in 2 weeks in Frascati. It's going to be hybrid, so you can also participate online in case you cannot travel to Frascati. And I think it's a very nice initiative in order to try to build the standards in order to push research towards the use of explainable AI, the use of artificial intelligence for extreme event modeling and understanding. Thank you so much for the invitation. Keep looking forward to the discussion now.
Pardon me, I was still muted. That's fantastic, and I look forward to diving in and learning a bit more about the standardization efforts. Great. Akisha, I'd love to hear a bit about your work, the data you utilize, and the role, if any, that AI or machine learning is playing or planning to play in the future.
Yes, okay, yeah. Thank you again for having me. So as you mentioned, as Geneva mentioned before, I am a senior planner on the MTA's Climate Resilience Planning team. And our team, we're responsible for evaluating current and future, very important keyword there, future climate hazards throughout our whole MTA service region. And the goal of that is to inform capital planning and investments across all of our operating agencies. So with that, I don't know if so many people are familiar. We don't just have like the underground subways, MTAs also, the agencies for Long Island Railroad, Metro North Railroad, Staten Island Railroad, bridges and tunnels. So we want to incorporate climate resilience in everything we're doing, capital planning wise across all of those agencies. So some of these hazards include coastal storm surge, sea level rise, torrential rainfall, extreme heat. So those are like the big four. There are others, but those pose the most risk towards our system. And what you're seeing here in the slide is the cover to our first climate resilience roadmap that the MTA released last April in time for Earth Day. This is just one of the efforts that was led by our team. And there you'll see the findings that we have from the climate vulnerability assessment we did. So we did a system-wide assessment to see if our infrastructure was exposed now and in the future to those different climate hazards that I mentioned. And we also outlined the goals and strategies that we're putting in place to mitigate those impacts currently and in the future. So for the data sources, so that we keep things in transparent and everyone's able to know what we're using, we use publicly available data. So we use data from like FEMA, NOAA for like coastal storm surge and sea level rise. New York City actually released some stormwater flooding maps for the city for current and future conditions. So we're able to capture some flooding from inland flooding from heavy rainfall events. Now for future projections, New York City, we're very fortunate because we have the New York City Panel on Climate Change, which is this science advisory board that is put together and nominated by the mayor and the mayor's office. And they actually produce future climate projections for New York City. So having that local information was very important, very key to our planning and to be able to do and conduct this climate vulnerability assessment and develop some of those strategies. So it's the rundown of, of how we're applying it. So right now we're leaving some of the climate information, the AI and machine learning to those who are producing the data that we use in this case, but that's how we have like directly used it in decision making in our case of the MTA.
Fantastic. Thank you so much. I will stop sharing my screen and I will allow Terry, you should be able to share your screen now and please kindly introduce your work and the type of data you work with. Oh, I think you might be on mute still.
I can't believe I still do that after all this time. But it's good to be here and to be among the other presenters. My name is Terry. I'm from Howard University, as I was introduced, and I've been conducting interdisciplinary and multidisciplinary research looking at issues related to emergency management and disaster response. My roots are in criminal justice, meaning that I first started out looking at criminal justice issues, but the Hurricane Katrina really moved me to thinking about how could we improve response to disasters, seeing what unfolded and seeing victims of the disaster stranded and in desperate need of help. And so since then, I've been engaged in looking at issues related to emergency management and disaster response. While there are a number of data sets that are available to be used, including FEMA's National Household Survey on Disaster Preparedness, most of the work that I've done over the years really involves the collection of data, both qualitative and quantitative data. As we all know, quantitative data allows you to really generalize and those data sets are more easily adaptable to um, developing models and training models for prediction. But I like to also collect qualitative data because I like to hear from people what have been their experiences and how their experiences from the past, taking a prospective, retrospective analysis of what they've experienced informs what they expect to do in the future in the case of potential new disaster experiences. You'll see on the slides a list of projects. This is just a few that I've been engaged in with my students over the years, including some that are current. I've been fortunate to have funding from NOAA examining different kinds of products and how that impacts decision making, working with folks at the National Severe Storms Laboratory for a couple of years, and also having a shared postdoc with the Geospatial Laboratory as well. Also, I have had the opportunity to examine the impact of culture on decision-making practices for emergency managers in both the United States context and in Taiwan, as well as examining risk perceptions after the Hurricane Maria and Harvey in Puerto Rico, as well as St. Thomas. And one of the current projects I'm engaged in is examination of behavioral responses to different kinds of risk communication on decision making. And we're exploring the role of AI on helping to improve messaging during disasters. I'll stop sharing now.
Fantastic. Oh, that's so fascinating. I can't wait to dig in more. So thank you all for providing a background to your work. My next question is about accessibility and the usability of data for disaster management. So from your very diverse vantage points, I would love to hear from you about what are some of the gaps that persist between what we have available for data and tools, such as, decision support systems or hazard maps, and the real world decision making that's needed for disaster management and climate resilience. Um, I'm curious to hear about the perspectives on accessibility and usability from, a policy or a research and all the way to a household or individual level, and where you see AI being able to further fill those gaps. Miguel Angel, we can start with you.
Sure. I think we have many sources of information, many sources of data, and each of them with in the end with particularities in the end, with different spatial temporal resolutions uh, derived from different products. So we have the climate variables, we have the satellite imagery, we have crowdsourcing data, even it's something we are trying, even multiple sources of information, multiple modalities. We have textual information, we have spatial temporal information. And I think one of the big challenges, thinking from the research perspective, from the perspective we are in my particular case, dealing with machine learning, deep learning architectures, this data, we have large scale data, we have many different sources with different properties. It's not clean data in the end. We have some noise. We have some, even not for the input variables regarding temperatures or moisture, but also thinking about when modeling streams, if we want to model them in a supervised way, which can be risky because in the end, the streams are going to evolve, are going to change. It's difficult. We are going to have exactly an example of the stream we are going to live in the future. Still, these annotations from the events we already know, from the events already reported, are noisy in the sense that we don't have a clear definition sometimes of the streams. There are some streams which are maybe easier to identify the starting and ending points of a flood, for instance, but then for other streams such as droughts, it's very difficult to determine the moment the drought is beginning and the moment the drought ends. And we have persistence. It's a complex event to be modeled and with many sources of information at the same time with potential gaps. Somehow I would say that maybe, but this is a current effort on data curation, on trying to prepare data in order to provide it as input to the models, on data alignment, to try to provide multiple data sources or multiple modalities of data at the same time to the architectures. At the moment, there's a big effort in the research community in order to try to take advantage of all the sources of information we have, given that these events in the end are highly complex. So we need, as I think all information is useful, but at the same time, we need to find the proper techniques in order to combine these sources of information properly.
And really briefly, could you give us an example about the standardization? Like, what is one example of the standardization approach that's being taken by this global initiative that might help to reduce the complexity or the noise? Really quickly, I'd love to hear just a tangible example there.
I think at the moment the community is contributing with many databases or the sources of information, and it's important to align these sources regarding themes, regarding metadata, regarding somehow we need to annotate this information, geolocate the information. It's very important to provide latitude, longitude information in order to relate all these sources, because in the end, try to come up with the similar format in the sense that we have maybe we have a database for crops, maybe we have a database focused on or urban locations, and in the end, maybe we could be interested in, and we have seen that foundation models seem to be very powerful for downstream applications, for different applications after train. We could be interested in aligning all these databases, and with metadata, with teams, with some common standard approaches, we should be able, if we follow similar recommendations when collecting this information, when creating our databases, it's going to be easier then to align all of them, to provide all of them at the same time to a system to take advantage of all the information in parallel.
Fantastic. Thank you. Keisha, I'd love to know from your point of view on accessibility and usability, what are some of the gaps? And, in particular, if you could speak to perhaps what might be necessary improvements in data formats or tools. I'm curious about this issue of having the proper resolution of data needed for your work and some of the processes that were required to get there.
Yes, so I guess coming from the public sector decision-making side, from the tool perspective, like dashboards and things like that, what I'm noticing is that there needs to be more engagement with the end users. I feel like these tools, by the time they're made and created, it's kind of done, and it's like it may seem obvious and it seems great in theory. But now when it's time to really use this tool, especially in operations, emergency management, like you're in the field and you need someone to log in information and interact with this tool in real time, is it actually practical, right? Like somebody they have like gloves on and PPE, or there's an active like flooding event happening. And as mentioned earlier with the qualitative data, Terry, you were saying, that's something we want to capture too, but they don't have time, right? They don't have time to like try to capture what's going on and handle the actual situation that's happening. So I do see that as an opportunity, though, where maybe AI can step in, because maybe there can be some kind of voice prompt. They can have something in their ear where, yeah, you have the tool, but you can prompt it now to say, an event is taking place, start logging what I'm saying. And have, we have Google Glasses and things like that. I'm just trying to think, like if we had all the things and you could say, okay, like scan this image and it knows it's locking the lat long, it's taking the time, it can maybe even measure flow of water. That would be great. I mean, I maybe sound sci-fi right now, but that would be great, right? That would be practical. They can still use the tool in a way that makes sense in that active situation they're trying to handle. And we don't miss some of that qualitative information where like, oh, this flooding happened and it was this type of weather at the time. So all that can still be captured at the same time without adding an additional lift, right? Like we don't want to make it even harder for people to do their jobs, but still, we still need the data, but how can we make it a lighter lift for them to actually use the tool? Now, from the data format side, sometimes it seems very obvious, but I think there need to be more use cases and examples for how to use the data. I think there's a big gap there because it may seem like, okay, well, here's this flood map. Just go and see if your property is in the flood zone. But I like to think of it and explain it as this way. So, like when you're going to see an apartment or a house, right? And it's empty, it's obvious in the apartment, in the house, you're going to put stuff in it, right? But there's a reason why they stage these things, right? Because you're showing people how to use this space and it makes that connection for people. That's the same thing I'm thinking around data. Show people how to, again, it's a house and apartment. You know you're going to put stuff in there, but show people, make it real, like, oh, make that connection. Oh, okay. I can use temperature data in this way. Oh, I can use this flood map in this way for my planning. So I think sometimes people think it's just like an obvious thing to just use the data as it's presented, but not necessarily. So I think there's a lot of work that can be done around that. And then even for the formatting and putting the tools together, AI also poses another opportunity because maybe you can have the tool, but then you can have the AI aspect that can prompt people. I can say, hey, I'm a planner who wants to understand how I'm going to use temperature to cool this station going into 2050. Walk me through the steps for this tool so I can get the output I want. So there are a lot of ways to kind of integrate it and make it useful, hopefully through AI. But those are some of the gaps that I'm observing, at least from our side.
Fantastic. And we at one point had Keisha, I'm gonna just ask for a small follow-up. We in our discussions, we were talking about when you were developing this resilience plan based on the vulnerability plan for New York City. Um, and at the beginning, if I understand, there was large regional models. I'm really curious to know about if you can just briefly speak to kind of this downscaling need. That's a huge emphasis of LEAP, and I'd love if just really briefly you can give a little bit of background on how you got that data format, that data granularity to the space you wanted it, just really briefly.
Yes. So of course there are a lot of like data sets out there like, oh, New York, for the state of New York, temperatures are going to increase by this much, but that wasn't really as useful for us as planning because we have things very, very local, like these events are highly localized, especially for extreme rainfall, right? And a lot of our assets are along the coastline. So we really needed something way more granular than the average temperature in New York State or this much, sea level rise for the whole coast. That we were very fortunate because we had the New York City panel on climate change. If every state could have that format where they have a dedicated science advisory board and body that can focus on the local characteristics of that area, I mean, that would be great. But in New York, we're very fortunate that we had, the New York City Panel on Climate Change who did that work. They collected all of the available climate information. They did the downscaling and they produced those regional, very local New York City based projections for us. Because they understood that that gap was needed. And so that's why I guess that was prompted by the mayor's office to then have that occur. So yeah.
That's fantastic. And part of, New York City being such a large entity, it's able to kind of move in the direction it wants to. Um, Terry, I'd love to hear from your point of view on accessibility and usability of data and some of the gaps, and yeah, teasing out what you think is the most fascinating. And I'm particularly interested as well on this communication and engagement component, because I know you're working a lot with sort of the last mile, but please take it away.
Sure. Um, well, I like to think of this in terms of the different phases of a disaster. So I think right now, some of the tools that are available are appropriate and really useful in the different phases, whether we're talking about mitigation, preparation, response, or recovery. I think the phase that is most challenging is I was nodding my head a lot as Akeisha was talking because I think sometimes there's a difference between when a tool is actually developed and how it's actually used in the field. And I agree wholeheartedly that it's really important to make sure, and I know people who are producing these things are testing them, but to really think about how it's actually going to be used when everything you've ever known has radically changed and you're in the midst of a fast moving crisis. What and often decision makers rely on muscle memory, meaning they go back to what is the norm for them. And so in terms of developing or using these AI products, it's going to be challenging data integration, accessing data, because often in disasters, data is fragmented. And so, how can you gather that in an efficient manner? So that's one barrier, I believe. And then communication and as well as coordination issues. So there's often an absence of a centralized system to coordinate and disseminate new tools. How do we get them out or out to different members of disaster teams to make sure that everybody is in line or understands the usefulness of them and how they can be integrated. Um, and then there's ethical and privacy concerns for sensitive data that is used by emergency managers. How can that data be accessed and utilized, but still protect the ethics and the privacy of the public? In regard to crisis risk communication, one of the things that one of my colleagues and I within the Institute, Rachel Chapman, are attempting to do is to collect data on looking at how people respond differently to different kinds of crisis communications. Because as Akeisha mentioned, everything is localized. And so what I've found throughout the collection of data that I've done over the years is that people's perception of risk when they're looking at different crisis communication messaging now, it seems like they don't necessarily personalize it. So what we're working towards is developing or using AI in a manner that where it can be used to develop messaging that actually targets people so that they begin to personalize and respond appropriately to whatever situation that they're in the midst of.
That's fascinating. Thank you for that. There's a couple things you said I loved. Data is fragmented in disasters. It's, we often, for myself as a researcher, I'm often thinking about this in a very ivory tower type context. But then if you imagine yourself actually being in that situation, it is quite different. And I see in the chat, we have a thumbs up for there's often a huge disconnect between tech developers and the users they're developing for. Um, and I've heard there's a AI, generative AI kind of VR that's being proposed to be something to supplement emergency managers in these situations. So that can kind of put you also into potentially closer to a crisis zone and understanding how people make decisions. So perhaps it's something we'll continue to explore in this panel series. So for the last question for this morning, before we will go to some Q&A, I'm going to preface this question by reading from the mission statement that Terry had mentioned. She works, she's part of the AI Institute for Societal Decision Making, and their mission statement notes that decision making in disaster management requires complex, often life-saving decisions to be made under uncertain, dynamic, and resource-constrained circumstances, while also accounting for people's perceptions of risk and trust. So really teasing out what Terry was just alluding to. And I would love to hear from you all as we think about overcoming some of the gaps that we just mentioned. How do we work together as a community of climate and data scientists and policymakers and researchers and community members? How do we work together in terms of a collaborative process to ensure that the data, the tools, and the warnings are translated into decision making for effective disaster risk reduction, given the complexity? So I'm really curious to hear folks talk about this process of working collaboratively, bringing people together to address that disconnect between, the tech and the users. Miguel, I'd love to start with you.
I think it's a great topic to discuss maybe more than 10 minutes. This connection, I think we are doing efforts in order to try to connect technology with experts, with the requirements of users, what the users need in the end, but it's true that it's challenging. My point of view is that it's like we have different ways of communicating in terms of the data nature, but also in terms of how we speak, how machines speak. And of course, first we need to communicate ourselves. Before coming to artificial intelligence, experts from different fields, from the earth science, from the climate community, from the societal perspective, also thinking about the population, which in the end, it's our target is to help people in these emergencies. And also from the artificial intelligence, from the machine learning part, we need to communicate ourselves first in order to see what do we need, how should we model, what information is required. Sometimes we lack of, and I think this is a great opportunity. Panels like this, these are a great opportunity because we have the possibility of sharing our thoughts from the different perspectives. So then we can take into account all this information in order to design, in my case, from the perspective of machine learning, to design architectures tailored to the needs of users. Of course, it's true that this is a very, very challenging task to model natural disasters, to model extreme events. Maybe it looks like science fiction in the sense that still there is a lot of room for improving the models before coming into action, coming to real deployment. It's true that we can already do something, but still we need supervision from experts. We cannot leave entirely decisions to systems. I think that would be very, very difficult to achieve. Always we'll need experts. So first we need communications between good communication to pay attention to the different perspectives, given users, given experts, and then we need to build the communication between humans and machines. I think that's also important. The interaction between this is something we are living these days with large language models, when prompting, when asking for information, when trying to. This is something we are living already. these systems are also learning from our feedback, because in the end, thanks to the information we provide them, they are able to combine the information we provide together with the information they already knew, in order to provide better responses. Still, I think we can do an extra effort. Still, I think also these systems, this is something we are evaluating these days, if they have the capability of reasoning or not. And I think that's very, sometimes it seems they have already, sometimes it has been assessed that they could have some reasoning capabilities. And that would be very important, because if they have the capability of, they have cognitive functions such as perception or reasoning, that would be very useful in an emergency situation, because they could be listening to the environment in order to provide good recommendations for the users to better address the issues they are having at the moment they are suffering from streams. I think it's going to be, I'm looking forward to see how can we do with artificial intelligence in the upcoming years. But of course, I think it's a game of communication, communication between users, between experts, and also communication between machines and users in the end, in order to try to process as better as possible the information we have.
Fantastic. Yes, sometimes communication can seem radical, and yet it's
Yeah.
the basis. Um, Akisha, I'd love to hear from you on this process as well. You know, and from your perspective, I think it's really unique and brilliant to have in this conversation as well. Like, who do we bring to the table? Who do we know who to bring to the table? And how do we go about this process when you're actually trying to create something like usable data for your resilience efforts?
Yeah, so this is a great question, and this is something where we really need to work definitely on the communication, right? It's just the engagement. It's having forums like these to bring people together, because having the right people at the table, I think there's been a lot of not debate, but I think maybe not an appreciation for who should be part of these decision-making processes. So um, at least in our case, for our team, we have to communicate and work with all the agencies across the entire MTA, right? But how do we know? We have over 70,000 people who work at our agency. So just understanding who to bring into these discussions definitely is just trial and error, just an iterative process. For city and state level work, I think there's a lot of opportunity there to try and align efforts. So again, back to, I'm like advertising this New York City panel on climate change, but they're a really great example of showing how you can start to bring these different groups together, because there wasn't really a formal way that all of these different agencies across New York City were just coming to just have these conversations around their climate resilience efforts. And I've seen an uptick in that there's been more interagency communication. Oh, like what tools are they doing? We're doing all these climate vulnerability assessments and studies. So the New York City Panel on Climate Change, which is that efforts led by the mayor's office, they've been great about being like the liaison to bring in all of these different perspectives as for short, they're called the MPCC, is developing this assessment and report for New York City, because they want to understand, well, what do stakeholders want to know? What do we need to make decisions around climate and climate information? So I think it's been great to have a dedicated group or point of contact that aims to do that. That's like it's its own job in itself. And a lot of times we don't have that person who can act as that, I guess you could say, project manager, to kind of understand and see that bigger picture and just only focus on that, like, who do I bring? It's just maybe the designer, like, oh, well, let me invite this person or speak to this person. But you really need someone who can kind of position themselves to see that bigger picture and know how to start connecting the dots. So I think there's an opportunity there if they start to have these people who work solely on that, because that part is so important. It does warrant having its own position, honestly. So yeah, that's my take on that. And that's how our team has actually, like, that's the role we kind of start to develop into and evolve into at the MTA, is that now they have a pointed source, like this dedicated group to focus on climate resilience and making sure we're aligned, we're not duplicating efforts across the agencies, because they didn't have like that dedicated source to go to. So that's been very key in a lot of the work that we've been able to start to develop and discuss so far, including that roadmap.
Yeah, that's really fantastic, and just the role of that person that can kind of convene and see bigger picture. And also having a forward-looking, government entity that's willing to fund and support and bring that together, because this requires resources. So I think that's really critical as well, to have that sort of vision and acknowledgement of the gaps. And Terry, I'd love to pass it to you for your thoughts about what a collaborative process looks like. And in fact, you mentioned your project on the impact of NOAA projects on decision-making practices. I was really intrigued by that. And how do you get to understand this, the interaction between a tool and people, and how do we work together to better understand what's working and what's not?
Yes. So, to answer the latter part of your question, NOAA has various test beds, and sometimes there are opportunities for researchers to be able to um, participate in the testing of various products that there are that they are rolling out or seeking to roll out um, at some given point in time. And so I've been fortunate to be able to have those opportunities. In terms of, you know, how do you, um, who should be in the room, who should be participating, how do we really make sure that we're all are kind of on the same page, or have this awareness. I think it's important to make sure that, as I mentioned earlier, and Akeisha did as well, that as you're developing tools, that you are integrating people that are going to use them. I also think it's important to make the public aware of the kinds of tools that are being used, because as emergency managers and other disaster and decision makings, but mainly emergency managers are making decisions, they are thinking about, what is the best decision to make. But like everyone else, they are subject to being judged. And so, what are the ramifications for using new tools and helping to make decisions? Are there legal ramifications that they have to consider? These are the kinds of things that they are concerned about. I was just participated in an exercise at Emergency Management Center down in Tallahassee earlier this week, and those kinds of issues came up with the emergency managers. So they are very much interested in the advancement of the tools and being able to integrate the tools in their decision making, but they want to be able to trust the tools, and they are potentially aware that any decision that they make, they're subject to being judged by the people that, of course, they work for, but also the public. So, how do we increase public trust with AI and the use of AI in emergency management? I think all of that has to be a part of the equation.
Yeah, I think you brought up a really critical question, is trustworthiness of AI and responsibility. If you're using AI to make your decisions in a life or death, high stakes context, there's going to be a lot of public backlash. And I know, as Miguel Angel had mentioned as well, like, there still needs to be supervision. There still needs to be an ultimate decision maker. So, perhaps using AI as more, um, as a decision support tool that ultimately has expert advice filtered in. So, oh, this is also wonderful. I think we can open up to a couple of questions, maybe just for the next less than 5 minutes or so. Please, if there is anyone in the audience who would like to ask a question, please kindly do so now. All right, we have one that has come into the chat. So with the threats to, oh, and I've lost this, national science programs in the US, how are you navigating or adapting your reliance on data sets provided by government agencies? Terry, may I kindly just direct that to you first of all, and then perhaps to Akeisha, and followed by Miguel.
Yeah, it's challenging. These are challenging times. Right now, many of the data sets that myself and colleagues need to have access to are available. But that's changing. It's a highly dynamic set of circumstances, I should say. So I think it's important for us to continue to do the work that we do in the face of what is happening. And I know as funding shifts are made or priorities are adjusted, that it will be more challenging to access not only data, but the funding necessary to continue the work. But I think as a community, we know how important the work is. I know that most of us are very dedicated to the practice of what we do in the hopes that we are saving lives and improving disaster management. And so I don't have the answer to how do we fill those gaps in what's being taken away, but I am a strong advocate that we somehow find a way to continue to do the work that we do, and that we maybe build more collaborations so that we can make it through this period without gaps in the development of knowledge.
Very well said and encouraging in this time. And this is a very passionate space of people. Keisha, do you have any thoughts on the data needs and potential changes that we might be facing?
Yeah, that's a great question, right? Especially since I said we use publicly available data and mentioned several federal agencies. But as you had mentioned earlier, that we're fortunate in New York and New York City that we have, people are championing for climate resilience, and we do have the capacity, have some databases where we can have these city generated different versions of the climate data that we are using in the meantime. So I think that's why we're okay, just specific to our region, our state, our city. But beyond that, yeah, we're also just working and doing what we can, what we have while it's here right now. And just, yeah, we're gonna just keep going as best as we can. That's the best I could say on that. But right now, the data that we do use, it is still available. Last I checked.
Fantastic. And we've had this discussion as well within LEAP, and thinking about collaborations with planners and decision makers. And, as some research centers that are on, 5 or 10-year funding contracts, there's a hesitancy and a riskiness of depending operationally on something and a scientific output that might be shorter term than what we can usually trust as a durable, predictable, continued data output, such as NOAA or FEMA maps. And I think that's really an interesting tension now. And, thinking about collaborations and how working together and what gap we can fill, and where does the role of academia come in here to start to fill some of these challenges and these gaps in data that we might see going forward. Miguel Angel, do you want to respond briefly to this point?
Very, very briefly, because I have to say I have little experience with data sources in US. I think it's a very, very interesting question, even for our working group in data at the Global Initiative. I think it will be an interesting discussion for one of our meetings. I would say that in the end, still we have different sources of information to compare. I think we should measure uncertainty when coming to model to training models. We should measure uncertainty of the data, and of course, data is going to change through time, and not only because of environmental conditions, but also because of the way we are capturing data. Probably in the future we'll have better systems to capture data, and still we would like to align the data we are capturing at the moment with past data. So by comparing data, by measuring uncertainty on the data we use for training our models, one of the last topics we covered in the working group of data 2 weeks, 3 weeks ago, I think it was data drift, the evolution of the data through time, how the systems should adapt to this new data coming, because in the end we have already some trained models. Data is going to come in slightly different ways because we have a trend because of the conditions changing, and we have to see how to adapt rapidly our systems to these data changes. I suppose it goes into that direction, given that if we have that, still we have to measure uncertainty, and still the good thing is that we have multiple sources of information to compare.
That's useful to know too. Yes. So before I close, I'm wondering if I can just get a couple words or a sentence from each of you as a parting question. And thinking about some of the science or data providers that we work with, especially in the university setting, what is the most important thing that the science and data providers could do to foster more relevant and usable data and tools for the types of folks you work with? Just in a couple of words or a sentence. Akisha, I'd love to start with you.
I think the theme is to keep having conversations. We have to keep engaging and interacting and just making sure that we're getting the inputs that are needed as we're developing these tools, and as decision makers have to use and engage with these tools. Miguel, as you said, like interacting with the actual AI and machine learning process, because who's training the tool is just as important, and training this data, right? It's just as important as who's going to be using it at the end, because that also influences what is coming out of these models. So just keep having these conversations. Like they say, write the vision, make it plain, make it very obvious what it is you're trying to do, and then it will draw in, I guess, eventually draw in the right people.
Terry, your parting thoughts on this.
Sure, I totally agree what was just said, and I think it's important to not only think about the decision makers that are using the tools, but also acknowledge that sometimes there are biases that are embedded in some of the models, and we should be cognizant of what they are and seek to make sure that they are addressed, so that as they are put out on the market for decision making, that it doesn't impact the decision makers' ability to provide the best services possible under stressful circumstances.
Well said, thank you. And Miguel Angel, some parting thoughts on what we need to think about to have relevant and usable data.
I think the main message from communication in all directions and regarding all the people and machines involved in these situations, in these emergency situations, I think it's very, very important, the communication. Also, I would say the alignment, this is very, very huge. Data, multiple sources, to have the computational resources, the proper access to the data. At this moment, I think we have probably copies of the same large-scale database in many, many servers. It would be interesting to have a common server at which we could, where we could align all the different data sources, but also we could access in order to conduct our experiments, that would be very, very nice.
Mhm.
Thinking about all these ideas of digital twins, having a server not necessarily have to have duplicates of the databases, but a common server, huge server at which the communication, also the data transfer is efficient. I think from the research perspective, it's also relevant. But of course, first of all, communication between experts, between machines and humans.
Brilliant. Thank you so much. Thank you to the panelists and to the attendees. This is a continuing series. You can access the recordings and the literature and summary blogs in the LEAP website. I've put it into the chat. These are all accessible online, so you can go back and watch everything. And I'd like to plug our upcoming and last session of this academic year on May 16th, Friday at 10 a.m. as well. We're going to look at AI for wildfires and heat waves, exploring Google X's Bellwether project, and Medusa, which is the Mediterranean and Pan-European forecast and early warning system against natural hazards. And yeah, I have also put the link to register on Eventbrite in the chat. So thank you again. This is such a fantastic conversation. It's just incredible work happening, and I am thoroughly delighted to be able to write this up and continue to engage with you all. And thank you for the work you're all doing.
Thank you.